There are 5 different types of reactions that you should be able to identify. All 5 types can be found on page 6 of your reference table. So it's really important that you have those reference tables and that you're looking at page 6. You also need to remember that a reaction goes from reactants to products. Reactants on the left, products on the right. So the first type that we have is a synthesis reaction. This is when you take 2 or more reactants and you form one product. So the way we can identify synthesis reactions is by seeing that there's one product, one substance on the right side of the arrow. The second type is decomposition. This is when you have one reactant and then it breaks down into 2 or more products. So we know it's a decomposition reaction when we have one substance on the left of the arrow. Single replacement reactions are when you have an element and a compound on both sides of the arrow. So the element is being switched with one from the compound. So the element on the reactant side is different than the element on the product side. Double replacement are the ones that look the most complicated because you have 2 compounds on both sides and they're just switching partners. The last one is probably the funnest reaction, and that's combustion. So you have a hydrocarbon, which is what the CXHY represents, where X and Y can be any ratio. It reacts with an oxygen molecule to form carbon dioxide and water. When a combustion reaction takes place, it always forms carbon dioxide and water, and it releases heat and light. So if we look at our first example here, what type of reaction would this be? I want to key into the fact that there is one substance on the left side of the arrow, so there's one reactant. And when we have one reactant, it's a decomposition reaction. Take a look at this one. Here we see that we have a hydrocarbon, hydrogen and carbon, and it's reacting with oxygen to form carbon dioxide and water. So that is a combustion reaction. Always looking for that hydrocarbon plus oxygen, giving you carbon dioxide and water, you'll know it's a combustion. For the next one, notice that there is one thing on the right side of the arrow. So we have one product, and when you have one product, it's a synthesis reaction. In this next reaction, we have 2 compounds on both sides of the reaction, so that would be a double replacement. 2 compounds on both sides is a double replacement. Here we have an element and a compound on both sides of the reaction. The order doesn't matter, it's just on which side of the arrow is it on that matters. So because we have an element and a compound on both sides, that would make it a single replacement. Now you can see that I've abbreviated double replacement and single replacement as DR and SR, and that is perfectly acceptable. Here we have 2 compounds on both sides of the arrow, so that again would be a double replacement.